let's begin. All right. Second. Okay. I always like to start with a little review. All right. So let's say that I have to simplify this expression right here. Right? What do you think that I should do? I'm saying? Say it again. Okay. But there's no like terms in the parentheses. So what's the only thing that I could do here? Not division, but you're close though, something else. Multiply, right? Or specifically distribution, right? So I want to take the coefficient, the number that's in front, and just distribute that. And that's it, right? So let's do that. 3 over 2, this is going to become 3 over 2 times 12x over 1 plus 3 over 2 times 20 over 1. Now, I'm writing the 12x over 1 and the 20 over 1 because anything divided by 1, is the top number. It makes it easier so that you can see it's a fraction times a fraction, right? Now, how do I multiply fractions again? Not across. Oh, yeah. But how? Like this or like this? Nah, straight across. Straight across, right? But what you could do is you could reduce it before you go across, right? So let me show you a reduction. So 2 goes into 2 once, 2 goes into 12, right? 6 times. So then all you have to do now, 3 times 6, right? 18x. You could do the same thing with the other side, right? 2 goes into 2 once, 2 goes into 20 10 times. 3 times 10, 30. And that's it. Questions on this?
Why do they in the 3 and 1? Do we not with the much trade with this?
It would be the reverse. 1 goes into 3. All right.
But what is the
It would give the same answer, yeah. Because I would say 1 goes into 1 once, 1 goes into 3 3 times. So it's the same multiplication. Yeah. Yeah. All right. Questions on this though? Are we good? All right, let's do another little recap real quick. How about this? I want to simplify this expression. So I have 5 minus 2 times n plus 1. What should I do first? Distributing what? Just the 2? Huh? No, can't do that. What's in front of the 2? The minus sign. That's what I'm trying to get you to say, right? So what you're going to distribute is actually this whole thing -2, right? So -2 times n, and then -2 times 1, right? So now what does this become? This becomes 5 minus 2n minus 2. After you get to this stage, what should you do? Combine like terms, all right? So what is it? Tell me the answer.
5
Say it again?
minus 2.
Right. 5 minus 2n minus 2. So combine like terms, what do you get?
So we have, sorry, I was looking at my answer.
Got you.
3 minus 2.
3 minus 2n. Very good. Right? So our 5 and our -2 are like terms. You just add them together, right? So 5 plus -2, +3. And then that's it. Questions on this, anybody? We good? All right. Let me get one little blast from the past and then we'll keep it moving. So over here, I want to find the LCD of 5/6 and 1/4, right? Remember we did that yesterday? So what would be the LCD of this, the least common denominator of these two fractions? What do you say? In other words, like what is the largest number that 6 and 4 goes into evenly? No, 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 not the number that goes into them, the largest number that they go into, the reverse, not 4. 6 can't go into 4. So I'm looking for some big number, right? Like 100 or something that 6 and 4 can go into evenly. But I'm not looking for the biggest. I'm looking for the smallest big number that they can both go into. Eight? Well, 4 could go into 8, but 6 can't. 12. That's it. Right? So let's recap how we could do this again, right? We know that 6 is what? 2 times 3, right? And we know that 4 is what? 2 times 2. Easiest way to do it, take one of the numbers, right? One of the sets that are there. It doesn't matter which one, just take one, right? I'm gonna take the two and the 3 for the 6 on top because it's on top. Literally, that's the only reason why. So 2 times 3, right? That's the top portion right here. And then all I have to do is look at the second set. Now I already have a 2. I already have 1 2 in the what you call it in the LCD here, but in the 4 I have 2 of them, right? I have two twos, so I need to put an extra 2 here to make it complete. So that's how you get your LCD right there. So 2 times 3 times 2, which is 12, as you guys said. All right.
Usually on the two centimeters to a region complete to get to 12.
Yeah, if you multiply them straight across, you get to 12. So like this is a method, a way of finding the LCD if you can't tell just by looking at it what it is, you know. Um Another way to do it in your head, I'm not really a fan of head work, but another way to do it in your head, you know that, for example, 4 can't go into 6, right? So then now double the 6, 12. Can 4 go into 12? Yes, then that's it. That's another way you could do it. And even if you did it in the reverse, right? Take the 4. Can 6 go into 4? No, double it. All right, 8. Can 6 go into 8? Not evenly. It goes in once, but not evenly, right? All right. So then keep going right there. Right? So times 3. So 4 times 3 is 12. Can 6 go into 12? Yes, it can. All right. So that's another way that you could do it in your head. But again, I'm not a fan of head work. All right, let's take a look at what we're gonna get into now. So we want to solve linear equations using a general strategy. So solving an equation is like discovering the answer to a puzzle. The purpose in solving an equation is to find the value or values of the variable that makes it a true statement. Any value of the variable that makes the equation true is called a solution to the equation, right? It is the answer to the puzzle, right? You should. Yeah. I am recording it, so you can always watch it back too as well, in case you just feel like sitting and taking listening. That's good too. I just need to get y'all emails, but when this is over, talk with the administration and see if I can get that back. All right. Anyway, solution of an equation, right? A solution of an equation is a value of a variable that makes a true statement when substituted into the equation. Period. All right. So we're just gonna build some vocabulary, then we're gonna do an example. I promise you this is real easy. So there are many types of equations that we will learn to solve. In this section, we'll focus on linear equations. All right, so we're gonna build it up. We'll start off with linear equations. So the heck is a linear equation? I'm gonna show y'all. All right. So a linear equation is an equation in one variable that can be written where a and b are real numbers and a does not equal zero, right? So for example, you have ax plus b is equal to zero, all right? All right. Make that a little bit bigger so everybody can see. So to solve a linear equation, it is a good idea to have an overall strategy that can be used to solve any linear equation, right? So in this next example, we will give the steps of the general strategy in solving a linear equation. Simplify each side of the equation as much as possible. First, makes the rest of the steps easier. All right. So here, right? Let's talk about how to solve a linear equation using a general strategy. Long story short, if you don't even remember like the strategy or anything, I'm just asking you to solve for n. That's it. Give me n equals dot dot dot, whatever. That's all I'm looking for. All right. So, ideas. How can I solve this?
Get n by itself.
I'm sorry?
Sorry, get n by itself.
Right, that's what I want. Yeah, yeah, that's what I want. I want n on one side and all the numbers on the other side. So what do we think that I could do here? What's some ideas? No wrong answers here.
Simplify left, so 7 times n.
Okay, let's do that. So you're saying I'm going to distribute the 7 over here. I like that, right? So 7 times n, it's going to give me 7n, right? And 7 times -3, that's -21. Minus 8 is equal to -15. What should I do after that?
Simplify further.
Right. So help me.
Finding what's the other eight.
Right. Good, good. And what does that equal? Negative 29. Perfect. Is equal to -15. That's great. What should I do after this now? It's a little tricky. Good, good, good. How exactly, right? So I'm missing 29, so I'm going to add 29 over here to get rid of it. But you know, I got to be fair. When I do the one side of the equation, I have to do the other side of the equation. So I'm going to add 29 over here. All right. So now I have 7n is equal to what's -15 plus 29? 14, right? Now I have 7n is equal to 14. How do I get n by itself? Divide. Good, good. So I'm going to divide by what? Not 14. No. What am I dividing by?
7.
The 7, right? The coefficient that I'm in front, right? Because that's going to get n by itself. But again, I got to be fair. When I do the one side of the equation, I have to do the other side of the equation. Divide by 7. All right? So now I'm just going to write it on the side over here. I have what? N is equal to, what's 14 divided by 7? 2. And that's it. All right? And you guys know I like to do my highlight thing. That's my thing. All right? Questions on this? Anybody? No questions is good? All right, let's keep it moving then. All right. The only thing that I would do a little different. I want to show you guys a trick. All right. I like to do this in another color, right? So when you guys are doing math, right? I don't know if you guys realize this, but getting an answer wrong in math is actually optional, right? You don't have to get it wrong if you don't want to, right? So how do you ensure that you don't get an answer wrong in math? You check it, right? So let me show you how you check an answer right now, all right? So this is to check the answer, right? You have the original equation right up here, right? Just write that down. So 7 times n minus 3 minus 8 is equal to negative 15. So what I want to do here is I want to plug in n, right? Let me just scroll down real quick. I forgot what n was. N is 2, right? So I'm going to plug in for n, 2 minus 3 minus 8 is equal to negative 15. Now here's my goal. I want to make the left-hand side equal the right-hand side, right? If the left-hand side equals the right-hand side, I'm good to go, right? That means that the answer works and that's a solution. Let's try it out. So what should I do first? Say it again. Not the 7, the parentheses, right? So what is it? -1, right? 2 minus 3, -1. So this becomes what? 7 times -1 minus 8 is equal to negative 15. What should I do after that? Exactly, right? So now I have -7 minus 8 is equal to negative 15. You know what? I should put a question mark on all of these, right? Because it's allegedly. I don't know if the answer is true or not, right? -7 minus 8 is what? 15. Right? So now I have negative 15 is in fact negative 15. The left equals the right. Therefore, I know that the answer that I found of n equals 2 is the correct answer. This is how you check an answer, right? Long story short, you plug it in. Mhm. Now, I kind of got spoiled where I don't really plug in my answers as much as I should, right? But just know that getting answers wrong in math class is optional. You don't have to get it wrong. You can always check for everything. Go ahead. No, no. When you're subtracting hold on, let me say that a different way. When you add two negatives, it remains negative, right? So think of it like this, like you owe me $7, and then now you went and bought something else, so now you owe me $8 more, right? Yeah. So yeah. Any other questions with this, or it makes sense? It's good? All right. Now, you guys took growth mindset, so I'll share some insider information with you about myself, right? So I'm actually an autotrophic learner, right? I learn by hearing, right? So that being said, sometimes I have a tendency to talk more than write, right? So I went through this whole process, but I didn't provide you any notes for it, right? So let me give you guys some notes for this process. All right. So this is the general strategy, the process, right, of how to solve a linear equation right here, right? So step one, you want to simplify each side of the equation as much as possible, right? Use a distributive property, right? You remember that's how we pull the numbers over to remove any parentheses, and then you want to combine like terms, right? Remember, combining like terms is a $900 word for adding, right? Step two, you want to collect all the variable terms on one side of the equation, use the addition or the subtraction property of equality, right? So what that is saying is, remember how in our last problem we had to add the number to the other side, or sometimes you might have to subtract the number to the other side. That's what that means, right? Step three, you want to collect all the constant terms on the other side of the equation and use the addition or subtraction property of equality, right? So I want to put all my x's on one side. Well, the variables not all my variables on one side, right? And then I want to put all my numbers on the other side, right? That's the goal, right? Step four, you want to make the coefficient of the variable term equal to one, right? So after I'm done combining like terms, right, there's going to be or there could be, excuse me, a number that's in front of the variable, right? Any number in front of the variable is called a coefficient, right? And you want to make that number one, right? So how do you make that coefficient one? You divide by whatever number is in front of the variable. So if I have 2x, for example, I'm going to divide by 2 to get it by itself, to get x by itself, right? Da, 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 da. And then, of course, use the multiplication or division property of equality. Da, da, da. State the solution to the equation. Step 5, check your solution, right? Substitute the solution to the original equations and make sure that the result is true. All right. Now, I'm not gonna lie, I'm guilty of almost always skipping this last step, but I want to empower you guys and let you guys know the truth that if you check your answer, right, you can actually prove that an answer is correct, right? You don't have to get it wrong. All right. So once again, getting math questions wrong is optional. All right. So if you guys want to go for A+ in math next semester or whatever, go for it. This is the secret. This is how you do it. You plug it in. All right. Go ahead.
It's a-
So you see, a second. When I jump into the next example, I'll show you. So look, this is going to be our next example that we're going to do, right? So it says solve 2 over 3 times 3m minus 6 equals 5 minus m, right? You see how the variable in this, the m, is to the 1 power? That's linear, right? If the variable is to the second power, that's quadratic, right? Third power, cubic, you know? Fourth power and above is polynomial. I'm sorry?
I think
Oh, there'll be a number on it. So I'll give you an example, right? So let's say that I have m to the second power, like a superscript to say, like this is m squared. And remember from yesterday, it means this. It means m times m, right? Very good candy. I should try it, right? And then let's say you have m to the third power. That means m times m, right? But what, I'm sorry? To the step. Yeah, yeah, yeah. We can go back to the steps. Oh, you were still copying it? My fault. Go ahead, man. Yeah. But yeah, so anytime you have a equation and it has a second power on it, it becomes quadratic. A third power becomes cubic, fourth, fifth, sixth, whatever, polynomial. Yeah. Different types of equations. Yeah. So I'm trying to think. We're definitely going to talk about a quadratic. Let me rephrase that. Let me take that back. Your next class will talk about a quadratic, right? We're gonna talk about linear. But yeah, so when you go to Math 28, that they will elaborate on the quadratic for you. When you go to pre-calculus now, that's when they'll do everything else. So to the third power, the fourth, the fifth, the sixth, etc. Right? You good? Got it? No, I got you. Yeah, of course. Once again, around lunchtime, that's when I'll get those practice problems to you. All right. So over the weekend, I want you guys to like really look at those practice problems. I want you to try it. If you don't understand it, use AI to and ask it to teach you how to do it step by step, right? Because remember, when we're taking our exit exam, we're not allowed to use calculators. So it makes no sense to ask it to just do it for you because you can't get a calculator on the exit exam. So ask it step by step how to answer the question. All right. If you guys need an example of that, just let me know and I'll run one for you at the end. All right. Wait, y'all still don't have y'all emails. Uh, there's no exponents listed, it's just always my year. Right. No. Yeah, yeah. All right, I'm gonna have to talk to them about y'all getting y'all emails. All right. So anyway, I'm gonna solve this right here, right? Sorry about that. I don't like this little pop-up thing right here. Just get that out of here. All right. There we go. All right. So I want to solve this, right? What should I do first? It's a little bit different because I have a variable on both sides. So yeah, what should I do? Okay. So tell me. Times what? Perfect. Perfect. That's what I like to hear, right? So I'm going to take the 2 over 3 and multiply that over here. I'm going to multiply it over here. Can't complain with that. So now I have what? 2 over 3 times 3m over 1 minus the 2 over 3 times 6 over 1 is equal to 5 minus m. Okay, did I lose anybody with that step? So I'm just distributing the 2 over 3 to both terms, right? I'm making the whole numbers over 1 because I want to make it easy to recognize that this is a fraction times a fraction, right? And then we just treat it accordingly, right? Reduce it if possible, then multiply straight across. That's it. That's how we do the fractions, right? So for the first one, tell me what to do. The first term right here. Tell me what to do. Right. Right. So 3 goes into 3 once, 3 goes into 3m, m times. What should I do after that? That was very good. Okay, okay. I understand what you mean. 3 times 3, 1, 6 times 3 goes into 3 once, 3 goes into 6 2 times. But still, let me come back to the first term right here, right? After I reduced it, I should, starts with an m, multiply, right? Straight across. 2 times m is 2m, right? Bring down your minus sign and then go straight across. 2 times 2 is 4, right? And that is equal to 5 minus m. What should I do now? What do we think? Good, good. Help me do that. Tell me what to do. Very good. That's what I liked. That's what I wanted to hear. So now 2m plus 1m becomes what, 3M, good. Good. If I'm not mistaken, that's the company that makes tape, right? All right. So 3M minus 4 is equal to 5. What should I do next? Exactly. I'm going to add 4 over here. And what I do to one side, I have to do to the other. So now help me out. I have 3M is equal to perfect. So now what do I want to do? I want to solve for M. So tell me what to do. Exactly. I'm going to divide by 3 on both sides. I do to one side, do to the other. So now what do I have? I have M is equal to perfect. That's it. That is it. Questions on this? Anybody? Good. Let's check it one time. Let's do black, right? I'm just gonna pull this to the side real quick. So I want to check this. I'm just gonna write it low. I'm gonna check this, right? So I have what? I have 2 over 3 times 3M minus 6 is equal to 5 minus M. And then I found that M equals 3. So I want to know if 2 over 3 times 3 minus 6, right? Allegedly, does that equal 5 minus 3? I don't know if they're equal, but I want to find out. So what should I do first? What do we think? Very good, right? So I got 2 over 3 times 3, 9 minus 6. And I want to know, does that equal 5 minus 3? I'm not sure. What should I do next? Before that, remember parentheses. Sorry. So say it. Perfect. So that becomes what? Good. So it's like 3 over 1 is equal to, and then we have, what's 5 minus 3? 2. What should I do after that? I have a fraction times a fraction. What do I do? Before that, though, you're right. That's what I'm going to do. But what should I do? We did it before. So that's sort of R. You should not round up. Yeah, not the weed killer. We should re reduce it, right? So 3 goes into 3 ones, 3 goes into 3 ones, right? Multiply straight across, we have 2 is equal to 2. And that's the check. All right. Questions on this? Anybody? So once again, just let you know, getting questions wrong in the class is optional, completely up to you. If you plug this in and it didn't work, right? Then that would be like an indication that maybe we did something wrong in our solving. So then that will prompt you to go back and do the correct procedure. All right? Go ahead.
Two, three, then five.
I could have done that. I could have. And it would give you the same answer. But it's a lot more work. That's it. So to avoid work, you kind of do this. You know? Technically speaking, if we're following the order of operations, we should have done it in this particular method, right? Parentheses first, then exponents, right? Then multiplication, division, and then addition and subtraction, you know? So the reason why we're subtracting first in the 9 minus 6 is because like that's the in the parentheses. So we gotta simplify the parentheses first. You know? And that's it. All right. So we can solve equations by getting all the variable terms to either side of the equal sign, right? By collecting the variable terms on the side where the coefficient of the variable is larger, we avoid working with some negatives, right? This will be a good strategy when we solve inequalities later on, right? It also helps to prevent errors with negatives, right? So basically what this is saying, and let me be clear, this is totally optional, right? But what it's trying to say as a strategy is if you have two variables, right? Let's say one of them was 5x and one of them was 2x, right? But they're on different sides of the equal sign, right? What they're saying is to take the smaller variable, the 2x, and move that over to where the 5x is, right? So that you could avoid making the coefficient negative, right? Because if we move we can though, we could move the 5x over to where the 2x is, but then we're gonna get a negative 3x, right? So we're trying to avoid having a negative coefficient, right? Again, completely optional. If you want to do it, do it. If you don't want to do it and you don't mind dividing by the negative, go right ahead. All right. Let's take a look at this. Tell me what to do here. A little bit more complicated. Say it again. The four? Okay, good. So you want me to distribute it? All right, good, good. Let me just get a nice color. Go boom, boom. All right. So now what do I have? I have 4x minus 1 is minus 2. Oh, excuse me. Ooh, spoke too soon. 4x minus 4 minus 2 is equal to, what should I do next? Good, right? Distribute the 5. All right, so 10x, very good. Very good. Plus 15, plus 6. All right, what should I do after this now? Starts with a C. I should combine like terms, right? So now on the left-hand side, I have what? 4x. What? Say it again? No, no, we're not at that step yet. I'm combining like terms. All right. So on the left-hand side, right? What is the what is that gonna be? It's 4x. What? Well, before we get to the other though, all right? I want to combine like terms. Combining like terms is a really fancy way of saying adding, right? So I'm adding the terms that look alike. So -4 and -2, they look alike. So I'm gonna add them together. And what do I get? -6, right? Add them, not multiply them, right? All right, so equals, and I have 10x here plus 21. That's perfect. So now, right, what the hint was telling you, you see, I have a 10x on one side and I have a 4x on the other. It's telling you to move the variable, the smaller variable, to the other side. But if you do it the reverse way, if you move the 10x to the other side, it's still right, right? It's just a suggestion, you know. So what would you guys like to do? I'll give you guys the floor.
You know, we use.
You don't have to always choose it. That's the recommendation that you do. You know, what would you like to do? We'll move the 4x. Let's move the 4x then, right? So I'm going to subtract 4x. But what I do to one side of the equation, I have to do to the other side of the equation. I'm going to subtract 4x from here. So now what do I have? I have negative 6 is equal to 6x plus 21. Okay, what should I do now? A little bit more complicated. Perfect, right? How do I get rid of a positive 21? Perfect, right? So I'm going to subtract 21 from here. But what I do to one side of the equation, I have to do to the other side of the equation. Subtract 21. So what do I get? What's negative 6 minus 21? Perfect. Negative 27 is equal to 6x. What should I do after this? Exactly. I'm going to divide by 6. And what I do to one side of the equation, I have to do to the other side of the equation. So I'm going to divide by 6. What do I have? I have to reduce this a little bit, right? So reduce it. Four. Mm-mm. So let's think about it, right? X, right? I have negative 27. Technically speaking, that's just what? Negative 9 times 3, right? And on the bottom, I have 6. What's 6? 6 is just 2 times 3, right? So the 3's will cancel out. Final answer is negative 9 over 2. That's it, right? So after that now, right? What do I want to do? I want to no. Can I have one, please? Oh yeah. Sure, no problem. Thank you. Yeah. This is the updated one? Could I get the updated one? I have 24 now.
Okay, so
Yeah.
I just printed this out because that's the latest one that I guess everyone else was updated except yours.
So yesterday, the someone came and took my I don't oh God, I don't remember her name. She has the pretty tattoos.
Kiara.
Yeah. So she came and took mine. But there was a name written in at the bottom that should have been added to this list.
Okay,
Mhm.
all right, so I'll find out about that.
Yeah, thank you.
Because everyone else is not the updated.
Thank
I
you.
didn't see any on yours, so I figured if you're saying,
Yeah, appreciate it.
but I still have more to do.
Yes, yes. Excellent. Yeah. Yeah. These good people. I'm sorry, did I get to the top for you? Oh, okay. Oh, sure. Sorry about that. Do you all want to see it plugged in or can I move on? Hmm? No, keep copying. I'm just asking the questions to the class. You guys get the idea, right? So if you're on a test, plug in your answer, verify that it's right. There's no reason for you to get any math questions wrong.
Yeah.
Hmm? Okay. So the 27 over 6, right? I want to reduce the fraction, right? So all I did was I just kind of broke it up using 3 because I could kind of tell that 3 goes into 27 and 6. 27 is negative 9, excuse me, negative 27 is negative 9 times 3, and 6 is just 2 times 3. Since they both have 3's, the 3's could cancel out, and then I'm just left with what's there. So negative 9 over 2. So that's how I got that. I can do that. Yeah. It would work out to be the same thing if I did that. Yeah. It should come out to like 9.5 if I did that, something like that. Yeah. I don't, but I have other pencils if you want. I'm trying to think. Upstairs in the library, they probably got a sharpener in case you want to sharpen yours like during lunch break or something. Right? Like an hour, I think. Yeah. But yeah, so if you want to sharpen it upstairs after, you could do that. Hmm? Okay. Just gonna pull this to the side real quick. Let me get another color. Let's try blue. All right. So I'm gonna do a check. All right. So what do I have? Well, you know what? Hold on. That was a little bit high. 1 second. Just bear with me 1 second. Okay. So I want to do a check. All right. So I have 4 times x minus 1 minus 2 is equal to 5 times 2x plus 3 plus 6. All right. So I want to verify that the answer that I got is correct, right? My answer that I found was -9/2. So I want to check if that's correct. So 4 times -9/2 minus 1. Hey, how you doing? Um, minus 2. Allegedly, that's equal to that side. Go ahead. I'm sorry? Him. Yeah. 5 times 2 times -9/2 plus 3 plus 6. Okay. Yeah, so all I'm doing is I'm taking the answer that we got and I'm plugging it in for X, right? Yeah, because it's from the original. So this is the original right here, and I'm just plugging in our answer, the -9/2 for X. Yeah. Marilyn, you have him?
You want to fish? Okay.
Yeah.
Um,
I didn't ask it.
Randall.
I didn't ask his name. What's your
Let me
name?
make sure.
Alex?
Alex. Hold on.
Okay. You're welcome.
Okay.
Can I can I get like an email of that or something of the roster? Thank you. Yes, please. Thanks. I want their emails. That's why. Thank you. All right. So now let's verify. I just want to verify that the left hand side equals the right hand side. I'm not sure. All right. So what should I do first? All right. Help me out. So this is going to become 4 times. That's an ugly 4. Let me try that again. Yeah, that's better. All right. Not +9. So look, let me do it down here, right? I have -9/2 minus 1. You remember that 1 is the same thing as 1/1, so this becomes -9/2 minus 1/1. Now, in order for me to subtract two fractions, I have to have the same what? The same what? Not variable, the same denominator, right? So what would be the LCD here? What would that be? Not 9. In other words, I want the bottom number to be the same, right? That's the denominator, the bottom number. So what can I multiply the bottoms by to make them the same number? What number can I multiply them? By 2, right? So I can multiply the 2 by 1. What I do to the bottom, I do to the top. And I can multiply the 1 by 2. What I do to the bottom, I got to do to the top. So this all becomes what? This becomes negative 9 over 2 minus 2 over 2. Now I can subtract. So what's negative 9 minus 2? Say it again? No, no, no. No. Negative 11, right? You owe me $9, now you owe me 2 more, right? So negative 11 over 2. That's what goes here. Negative 11 over 2, right? Minus 2. And I'm saying allegedly that's equal to 5 times. Go ahead.
You did negative 9 over 2 minus 2, it's supposed to be minus 1.
It is. But remember that 1 is the same as 1 over 1. And the only way that I could subtract two fractions is if the denominators are the same. Yeah. So what about this other side? I have the 5 out there. That's not the problem. I want to simplify the inside. So what should I do? Starts with an M. I should multiply, right? So 2 times negative 9 over 2 becomes no, negative 18 over negative 18 over 2, right? Because remember, this is 2 over 1, right? And negative 18 over 2 is when you simplify that. No. What's half of 18? 9. Right? So it's negative 9. Right? The easy way to have done that would have been to just cancel out the 2's, and then you have negative 9. All right? Okay, plus 3, plus 6. All right? What should I do next? What do we think? Not multiply. Oh, yeah. Okay. On the left-hand side, yeah, let's multiply. Remember that this is 4 over 1, right? It's a whole number. So what should I do? Starts with an R. Reduce it, right? So reduce it for me. Reduce this for me. Remember, when we reduce diagonal or we reduce up and down. So up and down, we can't do nothing, but we can reduce diagonally, right? So what is it? Mm-mm. So 2 goes into 2 how many times? Once. And 2 goes into 4 how many times? 2, right? So now just multiply straight across. So 2 times negative 11 is good. So negative 22 minus 2, I don't know, is allegedly equal to 5 times. What's negative 9 plus 3? No. So you owe me $9 and you give me 3. How much you owe me now? Right. So negative 6 and then plus 6. All right. What should we do after that? Now multiply. We could do our subtraction. Negative 22 minus 2 is negative 24. And I'm saying allegedly that's equal to What should I do on the right-hand side? I'm gonna erase this if this is okay, all right? This bottom part. So I have 5 times -6, which is -30 plus 6, right? Now we want to combine like terms, we want to add. So allegedly -24, right? Right. So what's -30 plus 6? Good. So -24 is in fact equal to -24. And that's it. That's how you check it. Mhm. Questions on this, anybody? So it's kind of like just remembering the order of operations. You plug it in, do the next step, right? You don't have to follow the same steps on both sides. You could do one side until it gets complete down to the answer, and then you just finish the other side till they match up. That's fine too. Yeah.
Is there another problem?
Hmm. Yeah, I got more problems. But I promise I'll get you to practice at lunchtime. What happened? 12. Yeah. If I finish this a little bit early, then I'll quickly run upstairs and get you the copies and I'll bring them back. Um, All right. So this is a little bit more complicated, but it's actually the exact same thing that we've been doing, right? Follow the same steps, right? We're gonna distribute, combine like terms, put all our variables on one side, put all our whole numbers on the other, solve for the variable, plug it in. It's the same thing, all right? So let's try this. Let's try this. Oh yeah, right here. You know what I'm saying? Yeah, if you guys want scrap paper or pencil or pen, I got y'all. I'll let you guys try it and then I'll jump in, show y'all how to do it. Yeah, ready?
Yeah.
All right, let's take a look. So what should I do first?
And,
Before that. Say it again.
but
Simplify, okay. So I'm trying to simplify the left-hand side first. What's my first step in the left-hand side? No,
Thanks about that.
no. -8 first. We can't subtract that first. Multiplication comes before subtraction and parentheses before that because that's multiplication. Parentheses first, right? So parentheses, then exponents, then multiplication division. Go ahead.
After you distribute, does it then the three on the next to -8 just becomes the new just times, right? It becomes multiplied?
No, it's still adding or
Still plus.
subtracting. Yeah. So now what do I have? I have 10, open bracket, right? 3. -8 times 2s becomes -16s. And now -8 times -5 becomes good. I'm just going to kill the bracket right there. All right. Equals. All right. What about the right-hand side? What should I do first? Right? The 15, right? Good. 15 times 40, 15 times this, right? So 15 times 40, oh gosh. What is that? 15, 30, 600. Thank you. And then now 15 minus 5, excuse me, 15 times 5s is negative, what's that? Okay, 75. S. Okay, there we go. I'm sorry, let me just move this box real quick. I apologize about that. All right, what should I do next? Before that, starts with a C. I want to combine like terms. So combine that for me. I have 10, open bracket, what? Say it again. Plus 3 to what? Right. So now I have -16s plus 43, close bracket, is equal to 600 minus 75s. Now listen, if you had 43 minus 16s, that's still correct. That's still correct. So however which way you have it is good. As long as it's a -16s and a positive 43, you're good to go. What should I do next? What do we think? Right. Now I could take the 10 and distribute that, right? So 10 times -16x is negative 160s plus 10 times 43 is 430 is equal to 600 minus 75s. What should I do now? I combine the 160 and the 75, right? Which one do you want to move? The 75? All right, we'll move the 75. So how do I get rid of a -75? Good. So I'm going to add 75s over here. But what I do to one side of the equation, I have to do to the other side of the equation. So I'm going to add 75s over here. All right. So what is -160s plus 75s? Go ahead. Um, uh, let me think. 90, 85, right? So positive or negative? All right, so -85s plus 430 is equal to 600. What should I do next? Exactly. So I'm going to subtract 430 from over here. But what I do to one side of the equation, I have to do to the other side of the equation. Subtract 430. So now what do I have? I have negative 85s is equal to, what's 600 minus 430? 130. 170, right? Yeah, 170. Okay. All right. What should I do after that? I have negative 85s is equal to 170. All right, so divide by the negative 85, right? Bring everything. But what you do to one side of the equation, you have to do to the other side of the equation. Divide by the negative 85. So now what do I have? I have S is equal to, let's reduce it a little bit, right? Now, you don't have to find the largest number that goes into it, like right off the bat. You could do it piece by piece, little by little, right? For example, we have 170 and we have 85. We know that 5 goes into it, right? Just keep it simple, right? So 170 divided by 5 is what?
What did you say?
170 divided by 5.
30?
I don't know. Let's verify. So 5 goes into 17. What's that? 3 times, right? 3 times 5 is 15. This is 2. Bring this down. So 5 goes into 20 4 times. 4 times this is 20. Subtract the 0. So 34. So this becomes 5 times 34. For real, I didn't know the answer. I'm just asking y'all. That's really good, though. It was a really good guess. 85. What about that?
25,
Mm-hmm.
11, 13.
Not 11. Something bigger. Let's see. So 5 goes into 8. We know 1 time, right? And 1 times 5 is 5. So 8 minus 5 is 3. Bring down the 5. So 5 goes into 35. How many times? 7, right? So this will be 7. And 7 times 5 is 35. Right? So that's it. So this is 5 times 17. Right? The 5s will cancel. So what am I left with? I'm left with 34 over 17. But let me ask you something. 17 goes into 34 how many times? 2 times, right? So this is what? Final answer is just simply negative 2. And that's it. So S equals negative 2. Questions on this? Anybody? Make sense? And you guys know how to check it, right? Just plug it back into the original. If the left-hand side equals the right-hand side, you know your answer is good. If it doesn't, there might not be no solution for this question, right? Which is a thing that actually happens, by the way. Yeah. All right. So I just wanted to do like a quick recap of something that we did yesterday. Just real quick, real quick. Here we go. So I want to evaluate 2 times x plus 3 when x equals 5. Remind me how to do this again? Not replace the x with 5. Good. So this becomes 2 open parentheses 5 plus 3, right? And what should I do after this? That's what I'm talking about. So this becomes 2 times 8, which is 16. That's it. That's full credit. Excellent. All right. Let's try one more. All right. A little bit harder. A little bit harder. Oh, shoot. So I have 1/2 base times height. What should I do here? Somebody tell me. Nothing complicated, just keep it simple. What should I do? That's perfect. That's perfect. All right. So then now I just want to multiply these, right? I could write those whole numbers as fractions, right? This is like 14/1. This is 9/1. What do you think I could do here? Don't overthink it. Reduce it, right? So 2 goes into 2 once, and 2 goes into what? Which one? 14, how many times? Not 6, not 4, not 5, not 3, 7, all right? Because 7 times 2 is 14, right? So now when we multiply straight across, what do we have? We just have 7 times 9 times 1/1, but you don't need to write all of that. What's 7 times 9? That's actually the hardest multiplication table on the entire multiplication table. Not 9, 63, right? 7 times 9. That's the hardest multiplication table out of all of them. Right there. Questions on this? All right. Just a little blast from the past from yesterday. You guys have the practice from yesterday where you can practice this more if you want. All right. I need y'all to practice on the weekend though.
You got that Friday.
No, just Monday through Thursday. And then Friday, Saturday, Sunday, we're off. Just continue to practice, right? I'm sorry I can't give you guys something more like concrete because I don't know the exam that you guys are going to take. It's the first time that they're doing it. So I'm just kind of giving you everything and then hopefully that'll be enough kind of situation. That's what's going on.
You go back to the last ball for X, this sounds like a long.
Oh, this one you mean?
Long, a really long one.
Which one? This one?
Reference. At the.
With the S? This one? Got you.
So it says right there, after you finish applying -8 to 2S.
Uh-huh.
Put it in more parentheses, right?
Yeah, I don't need it. Yeah, I don't need it no more after that. Because the 2S minus 5, there's nothing I can combine there. So after the distribution, that's it. And so -16S plus 40.
Say that again?
The parentheses that has 2S minus 5, there's nothing that I can combine in there. There's no like terms. So after I do the distribution, I don't need the.
There's a rule of thumb, I've always put parentheses around, their negative variables, that just seems.
Yeah, oh yeah, you could do that. Yeah,
like,
that's
it
legal.
really messes you up, because then you see 3.
Plus -16S plus 40.
Yeah.
Yeah. Yeah, that's fine. That's good. That works. And then
I just forgot to just.
Yeah. Yeah, and then you would distribute the 10, so you'd have -160S in parentheses plus 430, and then boom. Yeah,
Putting in parentheses just makes it seem like more perfect.
got you. Yeah. Yeah, it's not bad. All right, this is our last topic for today. It's kind of simple, nothing crazy. All right. So we want to solve a formula for a specific variable. So we have all probably worked with some geometric formulas in our study of mathematics. Formulas are used in so many fields. It is important to recognize formulas and be able to manipulate them easily. All right. So it is often helpful to solve a formula for a specific variable. if you need to put a formula in a spreadsheet, it is not unusual to have to solve it for a specific variable first. So we isolate that variable on one side of the equal sign with a coefficient of 1, and all the other variables and constants are on the other side of the equal sign, right? So let's look at the geometric formulas, right? Often need to be solved for another variable too. So let's say you have the volume formula here, which is equal to 1/3 pi r squared h, is used to find the volume of a right circular cone, right? When given the radius of the base and the height, in our next example, we will solve this formula for height. All right. This is not bad. So real quick, let me show you what we're talking about. So I want to solve this formula. V is equal to 1/3 pi r squared h for h. So basically, I want the formula to say h equals blah, 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 right? Let me show you how we do it. So I have the volume V is equal to 1/3 pi r squared h. I'm trying to move everything to the other side but h. I want h to be by itself. So first thing I'm gonna do, I have a 1/3 times pi times r squared times h. I'm gonna divide by 1/3. But what I do to one side of the equation, I have to do to the other side of the equation. Right? So now whenever you divide by a fraction, keep change flip, this is gonna become what? 3 times v over 1. Right? So I'm gonna keep the v over 1, change the 1/3 to 3 over 1, multiply straight across, you get 3v over 1.
Did you not,
Mhm.
simplify the right side, or is just 1/3? I don't know if I wanted something specific to quantum.
You could. There's nothing else to simplify on the right side, though. That's the issue.
Oh, right, because R is the.
Yeah. R is a variable. I don't know what R is. You know, the whole point of this is for me just to solve for H. Hey. So what should I do next? What's some ideas? So, appreciate you. Thank
The
you.
name was there. That was the one.
Oh,
What's the, yeah, it's a, so American says that's the new one, right? So it's right
yeah,
there.
yeah.
It just wasn't highlighted like my other list was highlighted.
But why only has 24? I mean 23, should have 24.
Not sure.
Something's missing. I don't know.
But this is the name that was.
Gotcha.
That was added.
Okay. All right. No problem. One second, you guys, 1 second. Okay. What should I do next? What do we think?
You know,
Or how did it get to be? So the V, remember that the V is a whole number, right? So think of that as V over 1, right? You want to change the division right here to multiplication. And then you want to flip the denominator, right? You have 1 over 3, you're going to flip that to 3 over 1. And then you just multiply straight across, and that's how you get 3v over 1. That's it. But back to the situation we have here. What should I do next? Divide by pi, right? And what should I do after that?
How would you divide by R squared? Or do you do that at all?
You can do that. That would be my next thing. I mean, to be honest with you, I could have divided by it right now. Because r squared and pi are just numbers. So I could have just said pi r squared here and then pi r squared here.
Oh, because it's attached to coefficient.
Exactly. And that would have worked.
Like would it work the same way if you separated them?
Hmm? Yeah, you just have to do it twice. But now look, I have a fraction divided by a fraction. You guys know what's going to happen. Keep, change, flip, right? So I'm going to keep my 3v, right? Change the division or multiplication. Flip the denominator. That should be it. All right? Okay, equals h. Questions on this?
Can you repeat the last time?
So you have 3v, right? And then pi r squared.
You spoke by our.
Right. So when you have pi r squared times h, just divide by the pi r squared, and it gives you the h. Go ahead.
Can you do, the, every equation?
Mhm. Every single one. You just solve for whatever variable they ask you to solve for, and that's it.
But it did tell you to, look at each problem, fine.
Absolutely. Yeah, just divide by r squared and h. There you go. Yeah.
But you write down the flipping of 3b and fires 3b divided by fire for
Like how to do it?
yeah.
Okay. So this would become 3v over 1 times.
Originally it would be divided by.
Oh, I see what you mean. You mean like this. So then do divided by 1 over pi r squared.
That's right. Everything
Yeah.
I was like trying to figure out,
Gotcha.
actually start off as 1 over or pi r squared over.
Then you do 3v over 1 times pi r squared, right, over 1. Multiply straight across, you get the same answer. So in the sciences, we often need to change temperature from Fahrenheit to Celsius or vice versa, right? If you travel in a foreign country, you may want to change to Celsius temperature to move more to yeah, to the more familiar Fahrenheit temperatures. Okay. You guys try. Try this out. I'm sorry? If I can scroll up. I'll say it again. Sorry. Oh yeah, absolutely. Yeah.
we want to solve this,
The F.
exact same way as we did the last one.
Mm-hmm.
But we'll simplify first, right?
Right.
Okay, that's,
So simplify the right-hand side and solve for F in particular. Go up or down? Like this way? Okay. We good? All right, try this.
the answer is supposed to be a variable and a coefficient variable. Or did I solve?
It should be a variable by itself. But it's okay if there's a fraction in the answer, it's fine.
by itself on either side,
Mm-hmm.
on both sides, one variable.
No, just on one side. So I want F equals whatever, everything else. All right, let's try this. So I have C is equal to 5 over 9 times F minus 32. What should I do first? I want F. Oh, nothing I could combine there. So what's next? I'm sorry? Okay, so what should I do with the 5, 9? Huh? Times it by F? I could. What's another thing that I could do with it?
Divide both sides by 5 months.
Divide by 5 over 9. What you do to one side, you do to the other. Right? So now, remember that C on top is like C over 1. You want to change the division to multiplication, flip the denominator. There. Right? Excuse me. What should I do after this? I forgot. Yeah. What should I do now? But before that, let's multiply this, right? What does that become?
E.
So 9C over
Five.
sorry, 9C over 5 is equal to, what should I do after that? Perfect. So I'm going to add 32 over here. What I do to one side, I got to do to the other. So now I have what? 9C over 5 equals what?
Oh, or wait, what? Wait,
Let's
see. Doesn't be.
What did we just add over here? 32. So plus 32.
Oh.
My fault. My fault. Equals F. This is my answer, and I'm done. Okay. Wait, what were you saying? Oh, sorry. Yeah. Tell me when to stop. Right there.
You,
Mm-hmm.
distributed the 5/9. Would you eventually get to the right answer?
Correct.
True, right?
You would. Yeah.
Okay.
I'm just trying to avoid as much math as possible. Mm-hmm. Go down. Gotcha. I'm sorry? From here. C over 1 times 9 over 5. So it's a fraction of multiplied by a fraction, you just multiply straight across. So 9C over 5. So 9C over 5 equals F minus 32. And I want F by itself, so I'm gonna add 32 to both sides of the equation. Mm-hmm. Yep, that's it. All right, try this. The same topic that we're doing, maybe a little bit more complicated. You solve for H. That's all I'm asking. We good? So we could do this step by step, but I feel like showing you guys a trick. I can actually solve this in 2 steps. Watch the 2 steps. All right. So I have S is equal to 2 pi r squared plus 2 pi r h. Right? Let me move that box. And I want to solve for h. Right? Here goes step 1. I'm going to subtract this entire term, 2 pi r squared. But remember, what I do to one side of the equation, I have to do to the other side of the equation. This is going to become s minus 2 pi r squared is equal to 2 pi r h. Here's the second step, right? I want all the coefficients, all the other variables in front of h to appear on the other side. So I'm going to divide by whatever's in front of h. So 2 pi r. But you know I got to be fair. When I do to one side of the equation, I have to do to the other side of the equation. So I'm going to divide the entire equation by 2 pi r. And that's it. That's the answer for h. H equals s minus 2 pi r squared over 2 pi r. That's full credit. Easy, right?
You go about it the
The other way?
Yeah.
Yes. Mhm. Yeah. You'll still get the same answer. Yeah. If I wanted, I could put the 2 pi r under both terms in the top and reduce that, but that's kind of like overkill. But if you want to see it, I'll show you. Say I have h equals, right? I can put them all under the same denominator individually, 2 pi r minus 2 pi r squared over 2 pi r, right? Technically speaking, on this side, I could cancel the 2's, I could cancel the pi's. I can cancel one of the r's, so cancel this, cancel the r, and then get a final answer. Get a final answer of s over 2 pi r minus r. This is another way if I wanted to go even further to solve it. But I would have been good with this answer right here. So the top part, hold on. Like up here? All right. So to me, right? Once they ask me to solve for a variable, everything else that's not that variable, I think of it as a constant, like a number, right? Technically speaking, R is a variable, but I'm treating it like a number, right? So because of that, that empowers me to subtract this whole first term right here, 2 pi r squared, and then just follow the rules. So I do the one side of the equation, I have to do the other side of the equation, right? So I put it on the other side. Then that left me with the 2 pi r h. Everything that's not h, for me, is a constant, like a number. So I just divided by 2 pi r over there. But what I do to one side of the equation, I have to do the other side of the equation. Go ahead.
You said it makes you divide by 2 pi r squared, right? Initially.
Subtract 2 pi r squared h, yeah. Yeah. Say it again? If I wanted to go further, like say I wanted it to be like bare bones, I can put both terms in the numerator under the same denominator and then reduce it individually. You know, that's another way to have done it. Go ahead.
But 2 pi r squared is treated as a single coefficient and variable.
Exactly. Yeah.
Because pi just has that special trait.
Yeah. Well, pi, we know pi is a number, but like
Yeah.
because it's not h is the real variable that I want, I can treat the rest of it like a number and just move it over. And that's the trick. Whether that's by adding or subtracting or multiplying, dividing, depending on how they're set up together.
Yeah,
Mhm.
okay.
Yeah.
It's the same as if you had a normal linear equation where it was like my s is equal to 2 plus
Right.
3 plus 2, you could just move all that over.
Exactly. Exactly.
Exact same.
Exactly. Yep. That's it.
Is there one more or?
Let me think. Yeah, let's go over one last example. I feel like you guys get the idea here though, right? Like we're solving for some variable that I'm telling you about. Go ahead. Mm-hmm.
You subtracted,
From both sides. Yeah.
you subtract the two.
The two. Hold on. Oh, at the top. Yeah, the whole thing. 2 pi r squared. That whole thing. That whole term. All right. I subtracted that from both sides.
And you do the minus two square r put on the other side.
Okay. Yeah. So on this side, these numbers are in front of the h, right? So that allows me to divide by all of them. They're all being multiplied, so it's the same thing, right? I could do it one by one, but it's just easier to do it like this as a cluster, you know? And it gives you the same answer in the end. Sorry about that. All right, let me do one last question. And then if you want, we could break for lunch a little bit early. But do come back. I'm gonna have the review sheet for you guys to practice. And then we'll call it a day after that at 3. So here we go. I have 8x plus 7y is equal to 15. I want to solve for y. Walk me through how to do this real quick. I feel like you guys have enough information that you could tell me how to do it. So go ahead, tell me how to do this. I want y, by the way.
Minus that 8x.
All right, so I'm going to minus 8x from over here. What I do to one side, I have to do to the other, right? So now what do I have? I have 7y is equal to negative 8x plus 15. What should I do next? Divide by 7. That's it. Divide by 7. What you do to one side, you do to the other. Boom, boom. You could either put it all under 1/7, or you could divide each term by it. In this case, I'm dividing each term by it. So final answer, what do I have? I have y is equal to negative 8/7x minus 15/7. If you want to do it, like subtract the 7y first. You could, but you're creating more work for yourself. Because remember, my goal is to solve for the y. So that's the one thing I don't want to touch. Yeah, because I'm trying to solve for y. So that's why I don't want to touch what it is that I'm trying to solve for. And that's it.
The divide by 7 where you can't put it under the whole.
Yes, you can. Yeah, yeah.
So it could also be 15 minus 8, that's divided by 7?
Yes.
Okay.
Yes. That would be work as well. Yeah. But
So we're trying to get rid of any number and get y by.
exactly. That's the goal. I want to solve for whatever variable that's being asked. And that's it. All right. So that's that. May I stop sharing? All right. That's going to give me an opportunity to post. Okay.